We all know that any number, for example, x is raised to the power of 0 is equals to 1. We all know that. But trust me, out of those people who know that, hardly 1 or 2% of them know why. So stay tuned if you want to know why. Hello viewers, in this video I have a special video arranged for you. I haven't been uploading for the past couple of days because I had no ideas, but now I have plenty of ideas and I will be uploading them on a weekly basis, not daily basis right now, weekly basis, because I have my other stuff to do also. You can see books. It's just this much, but literally still this much. So any number raised to the power of 0 is equals to 1. We all know that. Why? Let's figure it out.
Yes, so I'm going to begin by writing my name, of course, because I am solving this question. So let's begin now, and on this very dirty whiteboard over here. So I'm writing the question at the top, so I don't forget what I'm explaining. I'm explaining a is to power of 0 is equal to 1, and I'll put a box around it just to make sure that this is the thing that I have to explain in this video. Now we all know that x raised to power of 1 is equal to x. Now we don't care about the x, we care only about the 1. 1 over here can be identified as an instruction, or in other words you can say that it's an instruction of how many times we have to multiply the number by itself. It's written 1, that means that we have to multiply the number by itself 1, and we call this instruction a specific name by the term of power. So for example, yes, so I'm going to begin by writing the equation called x is raised to the power of 2 is equals to x times x. Because we have, it's an instruction, because it's an instruction of how many times you have to multiply x by itself. It mentions 2, so we mention over here 2x's. Now in this case, now when we have the instruction that x is raised to the power of 0, that means that we have to multiply the x by itself 0 times. In mathematics, we don't know, in mathematics, there will be, in this case, there will be something called error. Because it's an error, we don't know. We don't know x has to be multiplied by 0 times by itself. So the answer should be 0. But it's not 0. For example, over here, so instead of the question mark, the scientists say, that mathematicians say that we have to use something. There should be something, and this is where the multiplicative identity comes in. So yeah, multiplicative identity. Now let's say we write addition, subtraction, multiplication, and division. For each of these, we have separate multiplicative identities. Now for addition and subtraction, the multiplicative identity can be identified as 0, and for multiplication and division, it can be identified as 1. Now you may be confused, what and why, and what is this? So don't worry, let me explain you everything. Okay, so taking the equation x plus the multiplicative identity is equals to x. Now we need to, now multiplicative identity in this case will be, there are many multiplicative identities, but we're focusing on plus sign now. So for example, let's say 13. Yeah, the number 13. 13 plus what will be equal to 13? The answer, for example, in this case is 0. So the multiplicative identity for the plus sign is 0 for addition. For subtraction, it's the same. It's the very same. But what if it's for multiplication? So in the case of multiplication, it will be simply 0. Oh, sorry, 1. Yeah, it will be simply 1, because 13 times 1 is equal to 13. As simple as that. The same goes with the sign of division, because 13 times 1, or 13 divided by 1, is equal to 13. Or you can say x times or divided by 1 is equal to x. So in this case, 1 will be our multiplicative identity, and this is the multiplicative identity that we are going to be focusing on. So again, x is raised to power 0 isn't equals to 0. It's equals to 1 because the multiplicative identity comes in. So we say that x raised to power 0 is equals to 1. Now that's one of the proofs that I have today. If you want to if you want me to show you a direct proof, I also have that. Stay tuned. So for the second proof I have and the last proof in this video that I have, we need to use something called laws of indices. And one of the laws of indices, you may be know that x over x is to power a over x is to power b is equals to x is to power a minus b. You all know that. If you don't know that, you can study laws of indices in on Google or any online, you can say. But this is one of the laws of indices, and this is the one we are going to be focusing in. So instead of the denominator, if we make the numerator and denominator same, we all know that a number divided by the same number is always equals to 1. We know that, right? So in this case, x is to power a over x is to power a, because these two are same numbers and the numerator and denominator was the same, that means that the answer was equals to 1. Another example, in case of numbers, 7 square is equals to 7 square will be also equal to 1, because 7 square is 49, 49 divided by 49 is again equals to 1. Okay, so x is to power 6 over x is to power 6. Now instead of writing 1 again, why don't we rearrange the equation with the law of index that we used? So we used that x over 6 minus 6 if we apply that law of index or laws of indices. So the answer is simply is equal to x is to power 0. And since numerator and denominator are the same, you can see that x is to power 6 over x is to power 6 is equal to 1. And now by moving the x is to power 6 over x is to power 6, we left with this. And if we remove that, here's our second proof that x is to power 0 is equals to 1. Proof by Professor Burhan or student Burhan. So yeah, that's not for this video. Please do sure to like the video, share the video so more people know why any number is to power 0 is equals to 1. Subscribe to my YouTube channel and tick the notification bell for more latest updates. And yeah, that's enough for this video. See you in the next video. Bye bye.